Hi there, my name is Philip Simpson. I am your instructor for every class, and especially today, starting Chapter 9. Let's see. So I'm going to finish off some of Chapter 8. I don't think I finished some of these. As you can see on the left of your screen, I didn't finish some of those. Questions. So let's see. Okay. So, just a review. Cathode ray tubes helped prove what? They helped prove the existence of electrons. The volume of an atom is mostly what? Can you guys think of this? It's basically empty space. The vast majority of it is. Because you have your electrons orbiting a nucleus. But in between the electrons and the nucleus is vastly empty space. The atomic number is the number of what? Anybody have a guess? Protons. It's the number of protons. Neutrons also comes into play for the atomic weight. But, yep. All neutral atoms of an element have the same what? They'll have the same number of protons and the same number of electrons. Because they balance each other out. Protons have +1, electrons have -1. So they balance each other out to a 0. Atoms of an element that have different numbers of neutrons are called isotopes. The sum of the numbers of neutrons and protons is called what? The mass number. The gain or loss of electrons from an atom results in the formation of a what? Anybody guess this? It forms an ion. This is opposed to isotope. Isotope is whenever you add a neutron, add or take away a neutron. But in this case, we're adding or subtracting an electron. So let me go over a few other problems. I didn't assign any homework. But let's see. Let's see. Okay, we'll just go on to Chapter 9. And then one thing I need to go over is on page 222 of your textbooks. If you can get out your textbook real quick. As you can see here, let's see if it shows it. Let's see. Right there. You can see the atoms. You might need to freeze it so it's not shaking. But as you can see, like oxygen they have dots around them. And the number of dots is how many electrons. So you can assume anything is an electron. But in this case, I mean, you don't have to assume those dots around an atom are electrons. You can act like they're diamonds. Hey, we got some diamonds! And act like the letter is a person. So nitrogen could be Nick. Nick has 1, 2, 3, 4, 5 diamonds. And he might share those diamonds. Or he might need more diamonds to complete his octet. Say Nick likes 8 diamonds to complete his octet. So that's one thing you can do to make it easier. I mean, I barely know what an electron is. But whenever I look at the page, I assume that they're just dots. And it's a lot easier to play if they're just dots. Oh, here we go. I have it right here for you. So carbon has 4 dots there. Boron has 3 dots. Nitrogen has 3, 4, 5. So as you can see, as you go from left to right in the periodic table, you go from 1, 2, 3, 4, 5, 6, 7, 8. Except helium up here. Because that top level, to complete their octet, you only need 2 electrons. Just 2. And that'll complete their shell, and they're happy. But you go a step down, and that you need more electrons. Or you can imagine they're baseballs or basketballs, or ants, or diamonds, or cars. You can imagine they're anything. And it really does help if you imagine it to be something else. It'll help you understand it. And really, we're just like, if you imagine stuff, try to learn stuff a different way, it should help you. So, okay. Okay. So, let's start Chapter 9. Who's ready to start Chapter 9? Already. Let me move my textbook over. I like to sometimes look at my textbook as I go along. I do a lot of practice before I make this PowerPoint, but sometimes there's pictures and examples in here I like to share. So, first off, how are atoms held together? By chemical bonds. Not physical bonds, chemical bonds. That's how they're held together. What is a molecule? A molecule is the smallest particle of a compound. So, there can be 2 atoms in a molecule, but there can't be 2 molecules in an atom. An atom is smaller, and an atom will build up that molecule. So, what is a chemical reaction? A change in matter where different chemical substances are created by breaking and or forming chemical bonds. So this is kind of what you did in lab last week. Physical change versus a chemical change. Chemical change is something like where the aluminum breaks down. And it's going to be tough to read. I mean, you know it's chemical because the substance changes. Physical, like adding salt to water, you get salt water, you can kind of tell that at the bottom it's just wet. So it's a physical change. So let's see. Next page, please. Definitions. More definitions. Atoms. Smallest unit of an element that can exist alone or in combination with other elements. And a molecule is the smallest particle of a compound. Oxygen in the air is O2. Hydrogen in the air is H2. So as you can see there, oxygen is an atom, but in the air it exists as a molecule as O2. Sometimes O3, that's ozone. We're not going to get into that too much about the differences like that. I'll tell you when to think about stuff like that. So let's see. Next, more terms. We got 3 terms on this page. Terms are a great test question. So, chemical reaction. A change in matter where different chemical substances are created by breaking and or forming chemical bonds. Let's see. Yeah. So, let's see if I have an example in the book. Chemical equation. Let me look up an example of a chemical equation. Let's see. There we go. My page likes to jump around. Let me get it on the right. So here is a chemical equation. And one of the most common in the world. Water. It's a good chemical equation. It's a way to describe what happens in a chemical reaction. So, hydrogen and oxygen combine together to form H2O. Chemical energy. Energy can be stored through chemical reactions. And actually, I'm not for sure which way it is, but one of the 2 ways that this reaction goes, it actually releases a lot of energy. And if they can ever use this if they can ever harness that, I mean, that we would have an immense amount of energy on this Earth. Oh my gosh, my startup disk is almost full. I'm going to have to stop recording. Okay, am I resuming? I'm pretty pumped. I just found out why my computer has no room on it. It's because I had some videos on there from about 5 years ago. I think it was the Twilight Zone. I don't know. Okay, let's see. Electron dot, where were we? Imagine electrons are anything. Diamonds, baseballs, basketballs, whatever. Whenever we're looking at the atom, imagine it's just 2 letters. You don't have to imagine that it's actually neon with 10 protons, or carbon with 6 protons, or oxygen with 8. Just imagine it's an O with dots around it. Now you kind of need to know how many dots make it neutral, but you can learn that by just remembering its atomic number, which you should memorize according to the last class. So let's see. Valence electrons, or I call it valence electrons. They're the electrons that participate in chemical bonding. They're also the electrons on the outside of the atom. So an atom might have 30 electrons, but it's the 8 electrons on the outside of the atom that participate in chemical bonding. And so there's also something called the octet rule. And of course, to every rule, there's an exception. hydrogen, and helium. Because they are the first and second elements, they have a small electron shell around them. Just remember that hydrogen and helium have 1 or 2 electrons. They won't have a full 8. They won't have a full boat of 8. So, remember, valence electrons are the electrons that participate in chemical bonding. Okay, let's see. So, we got 2 examples here. Sodium, at the start of this example, here on 1, it's neutral. You don't have to know what makes it neutral. We're just telling you right now it's sodium neutral. It loses an electron. So it is kind of difficult when we talk about electrons because we're dealing with negatives. So if we were dealing with positives, I think everyone would understand it a lot better. Because, say, like, you gain $1. Well, you're +1. Gain another $1, you're +2. But here we're dealing with negatives. So it's almost like dealing with promissory notes, like in the old life game. I doubt many of you, I bet some of you remember life. Let's see. So sodium loses an electron and becomes sodium plus. Is it an isotope? Nope, not an isotope. Is it an ion? Yes. It does not become neon. Why am I asking you that? Well, sodium has 11 protons, neon has 10. But sodium, what we're losing here is an electron. So it loses an electron and it becomes sodium plus, but it still has 11 protons, so it stays there. What is its charge? Well, it loses an electron, so it becomes a positive. And just kind of loosely remember that atoms on the left side of the periodic table are more likely to lose an electron to get to an octet than gain 6 or 7 electrons. Can you remember that? Just remember that it's easier to lose 1 or 2 electrons to get to your octet, which a lot of these atoms like. They like getting to their octet, than to gain 6 or 7 electrons. Okay, we're back. So, let's see. Okay. Chlorine is on the right side of the periodic table. Chlorine gains an electron to finish up its octet. How do you know that it needs 1? Because on the periodic table, it's in the 7th family. So it's got 7 valence electrons. And it gains 1. So right here, chlorine gains an electron because it's got 7. So any element over here is going to want to gain 1. And it does not become argon, which would be if it changed protons. It changes electrons, it becomes an ion, and its charge is -1. Because it's got, let's see, how many? Gosh, dang. Thing's touchy. Because it's got, it's neutral right here at 7, so it gains an electron. Anything that is neutral and gains an electron will be negative. So let's see. Chemical bond. Let's see how many slides we got left. About 10. Not bad. Chemical bond is an attractive force that holds atoms together in a compound. So we got 2 types of bonds here. We have ionic bonds and covalent bonds. Guess what? They're different types of bonds. Guess what? Good test question right here. So we have ionic bonds form when atoms transfer electrons to achieve octet. electrons are given up and or acquired in reaction. So if I have a diamond and I share that diamond with, let's just say, pick a celebrity, Kim Kardashian. Poor thing just got robbed of her diamonds. But so if I was forming an ionic bond with Kim Kardashian and we had to transfer that diamond, I would transfer it to her and she would have it and we would not be touching. But if it was a covalent bond and I gave up that diamond, we would share that diamond and we would be touching. Me and Kim Kardashian would be touching. So it's common for atoms on the right side of the periodic table to form a covalent bonds. So remember, covalent, kind of remember like co-ed, like you share each other. Ionic, guess what? You form ions. But when you do that, they'll form a bond because one's negative and one's positive. So, let's go over the basic symbol and charge for these two. Aluminum. Well, let's see what it is on the table I got back here. Aluminum. 3 electrons. Let's just say it forms an ion by losing those 3 electrons. What's it going to form? What is its charge going to be for this isotope? Oh wait, it's not an isotope, it's an ion. Its charge will be 3+. And then a calcium ion. What is its charge going to be? Well, let's go back to the table. Calcium, if it loses 2 electrons, it'll be 2+. It's really quite simple. If you look at it and you try to think, oh, well, there are these electrons that are going around this atom of calcium that's got so many protons and neutrons. No. You're thinking about it too hard. You look at the table. 2 dots. Those are electrons. It loses them. It becomes 2+. So, ionic bonds. This is a good example here. You can forget about this, becomes oxidized and becomes reduced. What I'm trying to teach you here is that sodium and chlorine get together and form sodium plus chloride. Now they're going to be attracted to each other because they're ions. So for ionic bonds, chemical bond of electrostatic attraction between negative and positive ions. So electrostatic attraction is basically a fancy word for a plus and minus being attracted to each other. So 2 rules. Ions are formed as atoms try to get to octet. Ions are formed as atoms. Yeah, they try to get to their octet. That's what they want to do. Must be a balance between number of electrons lost and number gained. So electrons are not going to be created or destroyed. So on your left side of the equation, let's see. Neutral. Neutral. On the right side, we have a plus and a minus, which cancel out. So it's neutral. So the left side's it's going to cancel out with the right side. So let's see. Heat of formation. Okay. When a chemical reaction occurs and heat is released. So heat of formation. Let's break that down. You have formation right here. Think about the formation of an element. How's an element going to form? Well, just like right here, sodium and chlorine, they combine together. Sometimes, in a chemical reaction, heat will be gained or lost. like when we burn gasoline. It heats up your engine. Or when we burn natural gas. There's a heat of formation. When a chemical reaction occurs and heat is released. When a chemical reaction occurs and heat is released. To reverse the chemical reaction, heat is added. Back in. Remember, energy is never created or destroyed. So, the formula describes what elements are in the compound. And in what proportions. Sodium chloride contains 1 sodium and 1 chloride. Compounds held together by ionic bonds are ionic compounds. Use electron dot notation to predict the formula of a compound formed when aluminum combines with fluorine. Let's do this. So aluminum has 3 electrons. Fluorine has 7 electrons. Okay, this is going to be tough. Let's think now. Fluoride, fluorine. Fluorine. How's it going to do that? Well, if aluminum has 3 electrons it's willing to share, fluorine wants to gain 1 to get to the octet. Aluminum wants to lose 3 to get to the octet. Okay, so we need 3 fluorines because they want to each gain 1. So it'd be aluminum with 3 fluorines. Easy. So let's predict the formula of AlO3. Oh, I just gave you part of the answer. Aluminum is 3 plus and oxygen is 2 minus. Well, okay. Now, oxygen wants to gain 2 electrons. Aluminum wants to lose 3 electrons. So how are we going to do that? Well, let's think. The answer is AlO2O3. So you kind of figure that the least common denominator, or the lowest number that 2 and 3 both go into, is 6. So okay. Al2O3 is what that goes into. So covalent bonds. Okay. Here we go. Yeah, my room is a mess. So, okay. Looks like a short lecture overall. Let me try to fill that in some. Okay, so covalent bond is a chemical bond formed by the sharing of at least a pair of electrons. So hydrogen and helium, for example, can only share 1 pair of electrons. Remember that their octet is actually a duet. They have 2 electrons in their outer shell. But other atoms will share up to 8 electrons. And these atoms are all wanting to get back to 8 electrons, or the octet. So H plus H is H. And now imagine a dot right there and right there, and then 2 dots in the middle. And I'm going to show you this in lab. I should have this on the PowerPoint. I should have dots on it. Here you have H plus Cl. Well, guess what? The Cl has 7 electrons and the H has 1. So this goes together really well. HCl, 8 electrons. Let me see if this is in the chapter. It should be. Yeah. Chlorine plus chlorine, that's a good one. 7 and 7, how are they going to share? They'll share each one electron in a bond. And by sharing that one electron, they each get an octet. So imagine this is a solid line here. And imagine this is a solid line in here between HOH. Okay, so here we have, now we're going to go on and cover double bonds in the octet rule. So a double bond is when 2 pairs are shared, and triple bond is when 3 are shared. So H4C2, how is that going to form? Well, I'll just show you right here. Hate having to lift up the book to show you, but guess what? Let's see. Right there. Gosh, joke. Let me see if I can Google it. There we go. So there we go. You have a double bond there with an H's on each side. So let's count the electrons. Single bond has 2, 4, 6, 8. So carbon's going to be satisfied with their octet rule. Now if I drew an atom that had 3 bonds for carbon, 3 single bonds, that would not be possible because it does not satisfy the octet rule. So now let's see. H2C2. Let's see if I can find that. I like being able to Google stuff while I'm... Okay. I don't like that one. So, right here, H2C2. So, to figure out what the formula would be, you just have to draw it out. You know the H is going to have 1 bond to the carbon, and the carbon will need to have 3 bonds to something else, and the only thing it can bond to is the carbon, then to the hydrogen. I probably won't make you deduce this on a test, but what I will want you to do is be able to see if this makes sense or not. You're going to have to use the octet rule. And you're going to have to be able to relate this to H2C2. Now if I show you this formula right here, and I say, what's its molecular formula? I'd like you to say H2C2. So, okay, I'm back. Okay, let's go over some of the applying the concepts problems. So, which of the following is not true of a compound? Is it a pure substance? Is a compound a pure substance? No. Is it composed of a combination of atoms? Wait, which of the following is not true? I can't understand that problem. It's too confusing. Okay, let's move on to number 2. The smallest unit of an element that can exist alone or in combination with other elements is a... Remember, the smallest unit is an atom. The smallest particle of a compound that can exist and still retain the characteristic properties of that substance is a... what? Molecule. Remember? Remember, atoms can make up a molecule, but molecules cannot make up an atom. Molecule is a combination. Which of the following is an example of a monatomic molecule? So monatomic would be just one atom. And the answer was just AR, argon. The other choices were O2, N2, or O3. So I guess diatomic would be 2 and triatomic would be 3. So what determines the chemical properties of an atom? So remember, if we go back right here, remember last class I said like all the atoms in this column have the same properties. Not the same, similar properties. And these have similar, these have similar, 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 similar. The only things that are mainly in common are the electrons. So the electrons keep, or the valence electrons. So if I said electrons are what determine it, that'd be partially right. So if I had a choice on a test where you had to fill it in, and you said electrons are what determine the properties, I'd get most of the credit. But valence would be where it's at. So atoms attempt to acquire an outer orbital with 8 electrons. Where's that from? Or what rule is that? That's the octet rule. So the family or group number of the representative elements represents the total number of valence electrons. What is the chemical symbol for a magnesium ion? Well, let's just go back. Magnesium. It's got 2 valence electrons. So it's neutral with 2 valence, but it's an ion. If it loses those 2 electrons, it'll be 2 minus? Nope. 2 plus. So It'd be magnesium 2 plus. Atoms that achieve an octet by sharing electrons form. So by sharing, remember covalent shares and ionic transfers those electrons. So what's that attraction between a positive and negative ion if they're right up next to each other and it's keeping them there? What type of bond is that? We got 4 choices: electrostatic, covalent, metallic, or ionic. Well, we got ions. It's an ionic bond. So the energy released during the formation of an ionic bond is the heat of formation. Let's see. What is the chemical formula for the compound zinc chloride? Well, let's see. Is zinc on here? No. Zinc is 2 plus. Or it's got 2 valence electrons. Chlorine has 7 in each. So it takes 2 chlorines to match up with the 2 electrons of zinc. So the formula is ZnCl2. Pure substances that cannot be broken down into anything simpler are what? Are they molecules, mixtures, compounds, or elements? They're elements. Elements are as basic as you can get. Okay, let's do some more applying the concepts. So, what's chemical energy defined as? It's the change of internal potential energy during a chemical reaction. An ion can be described as an element or compound that gains or loses electrons. 20. You know that a chemical reaction is taking place if what? Chemical bonds are formed or broken. What is the relationship between the energy released in burning materials produced by photosynthesis and the solar energy that was absorbed in making the materials? The energy released is the same as the solar energy absorbed. It's very important. The energy that goes in is the same as the energy that comes out. That's pretty cool. I never thought about it that way. The tree will produce the energy that it stored from photosynthesis. Cool. The electrons that participate in chemical bonding are valence electrons. Remember that. Valence. That's important. I would really study valence electrons. Atoms of the representative elements have a tendency to seek stability through filling or emptying their outer orbitals. So by filling or emptying your outer orbitals, that means you're trying to get to the octet. And an ion is formed when an atom of a representative element loses or gains electrons to satisfy the octet rule. So an atom of the element of the 6th row, so this is 6, will have what charge when it is ionized? 2 minus. Which type of chemical bond is formed by transfer of electrons? By transfer of electrons? Ionic. Which type of chemical bond is formed between 2 atoms by the sharing of 2 electrons, with 1 electron from each atom? Covalent. Covalent is when you share electrons. What types? I think that's it. Okay, let's go over the homework a little bit. Let's see if I can't do some of the homework. I usually like to have the answers right in front of me for one reason. And that reason is I don't want to mislead you guys. Chapter 9, K and I. So, if you look at Chapter 9 problems, the answers are in the back. It's a lot like the problems on the right side of the table. And I probably need to cover polar covalent. So let's go back and do polar covalent real quick. Let's see. Basically, I just want you to know what a polar covalent bond is. Okay, we have electronegativity here. Electronegativity is the comparative ability of atoms of an element to attract bonding electrons. So, because every atom is different, some are better at going after other atoms' electrons. So, you're going to be given a table that lists all the electronegativity. And it's figure 9.10 in your textbook on page 242. And it lists all the electronegativities. And so a change of 1.7 would determine a ionic bond. Between that is a polar covalent bond. Less than that is a covalent bond. Now a covalent bond, or polar covalent bond, forms from an unequal sharing of bonding electrons. So, ionic bond, I mean, they transfer electrons. And then covalent bond, they share electrons. So in between that is kind of polar covalent, where some of the electrons stay on one side of the bond. So this will help you do problem Group B, number 7, which is part of your homework. So page 253, problems 1 and 7 from Group B. We can do Group A together now, but it's just straight from the answers. So 1 and 7 will help you. So there's a new homework policy. Once assigned, you have 1 week to complete for full credit. For 80% credit, complete at the second week. Once assigned, I will not make any exceptions, and I will not discuss the deadline by email or in person. Just read the PowerPoint for the deadline. You can email me your answers. So that's the new homework policy. And that's a wrap for this week. Thank you.